Okay, hello everyone. In this episode we're going to be looking at differentiating e to the x. And this is going to be quite an interesting episode because we have quite an interesting little derivative rule here that we're going to go through. But in this episode, again, it's just going to be looking at basic product rule, just getting used to e to the x. So it's a good sort of bit of elicitation about being able to differentiate with e in there. And my next video will be differentiating e to the f of x, so slightly more complicated, and we'll be looking at the quotient rule, whereas here we're just looking at basic differentiation and the product rule. So we'll get more advanced, but also want to point out that curve properties part 3, the video, will also be coming up soon, and we'll be looking at the second derivative in there, which should be nice and interesting as well. So first off, fundamental rule, the dy over dx of e to the x is itself. It's the only function whose derivative is itself. So the derivative of e to the x is e to the x. So if we look at the first question here, find the dy over dx of e to the x, it'll be e to the x. Simple. We've already crossed that off there. And the reason behind this is because, well, I won't go into the full first principles example right now, but with e to the x and differentiating it, it sort of means that anywhere on the actual function e to the x looks something like that. The slope at a given point is e to the x. I'll go into more detail in another video, but that's sort of the fundamental idea you should have behind why that's happening, as in what it actually means. So now that we've had a look at the very first question, let's make it slightly more complex, but not too complex, because this is our first video with e to the x in it. Let's have a look at the next question, the dy over dx of 4e to the x. And for here we just use product rule. We have two distinct terms. We have our f of x and we have our g of x. So there's our f of x, and e to the x is our g of x, if we were to label it like that. And we know, based on product rule, that the dy over dx, the derivative, equals the f prime of x, so the derivative of our first function, multiplied by the g of x as is, plus the g prime of x, multiplied by f of x as is. Hopefully you should be familiar with the product rule by now. If you're not, that's okay, but again, I'll go through it, so hopefully you'll understand. So the dy over dx of 4e to the x. Well, the derivative of a constant is the very first thing, and the derivative of a constant is 0. Then we multiply that by e to the x, because it's just the second function as is. And then it's plus, and we take the g prime of x. So what's the derivative of e to the x? Because that's our g of x. And the derivative of e to the x is, of course, itself. Pretty cool stuff. And then what we do is we multiply it by the f of x as is. And again, we can simplify that down because 0 multiplied by anything is of course going to be 0, and so we finally get 4e to the x. And we differentiated that. So as we can see there, it's quite interesting because the derivative is exactly what we started with as well. Ooh. And we can generalize this, because this is another question here. What happens if we get k e to the x, the derivative of k e to the x, where k is any given constant? And the answer, dy over dx of k e to the x, is going to be equal to k e to the x. Just like what we had there with 4e to the x, where we had the f prime of x and the g of x multiplied by the g prime of x and f of x there, using product rule. So isn't that quite interesting to be able to see that kind of relationship there? And now what we can do is we can cross that one off our board there, and we'll probably have a look at x e to the x now. So the dy over dx of x e to the x. And again we have two distinct rules, two distinct terms, using the product rule here. We have our f of x and we have our g of x. Our f of x is x and our g of x is e to the x. So what we do is we take the derivative of our first term, the x term, and the derivative of x is of course 1. And then we write the second term as is, just e to the x. And then we add the derivative of the second term, and the derivative of e to the x, I've said this so much this video, but it's e to the x. and then what we do is we just write the second term as is. And if we simplify that, the derivative of x e to the x is going to be equal to e to the x plus x e to the x. As you can see there, it's pretty straightforward. We just differentiate all our terms. That 1 times e to the x is just going to make e to the x, and x times by e to the x is going to make x e to the x. Nice and simple and straightforward. Okay, so now what we're going to do is we're probably going to look at maybe, let's see, probably y e to the x here, and that should be quite an interesting one as well. So I'll rub off some of this. Hopefully remember that the derivative of e to the x is, of course, e to the x. Pardon me. And the dy over dx, and we'll do this one, y e to the x. What we do is we again have two distinct terms here. We have our f of x, and we have our g of x. And again, we just apply product rule because it's two terms multiplied by each other. So therefore, the dy over dx is equal to, and we first take the derivative of our y term, and we know that the derivative of, well, again, this would be a relationship here, so I can't quite have equals there as of yet. But we'll just have that separate, because it's a relationship and we don't have y equals something, we can't technically have dy over dx out the front. But again, the derivative of y, if we remember from implicit differentiation, is actually dy over dx. So then we just write the second term as is afterwards. And then we add on first term as is multiplied by the second term's derivative, and the derivative of e to the x is e to the x, nice and simple. So now we need to find the dy over dx. I'm keeping this separate for a reason, and that's because y e to the x is, of course, not having y as a subject. Sorry about possibly confusing you there, but hopefully you picked up on it. And what we do is we isolate our dy over dx term. So let's just say that that was equals 0 there, it doesn't really matter. And we have equals 0 as a constant there, because even if we had a constant, say 6 there, we would have equals 0 here, because the derivative of a constant is always 0. And I've mentioned that in a few other videos, so hopefully if you watch me, there should be a cumulative knowledge to you. But again, let's just keep dy over dx on this side, and let's just, put negative y e to the x on this side. And again, I'm just inversing the operation because this one's going on holiday from the right-hand side to the left-hand side. And then we're just left with dy over dx, e to the x. And then we can simply move our isolated term, e to the x, into the denominator on the left-hand side. So we get negative y e to the x over e to the x. And that equals our dy over dx. Okay, so hopefully this video was reasonably straightforward for you. Hopefully it was quite interesting as well. In fact, we've probably got a bit of time. I might actually go through one more while we're here. Let's see, I might go through the dy over dx, so half e to the x now. But again, there's just implicit differentiation in action. And if you watch my implicit differentiation video, it'll be all fine. But again, now we don't have a relationship, we actually have a function here because there's no y mingling about on the same side as x. So dy over dx of half e to the x, should keep that in brackets. What we do is, again, we'd apply product rule, and the product rule says we should treat this as a term and we should treat that as a term. So this is our f of x, and this is our g of x. So therefore, the derivative of a constant, the derivative of half, is always going to be 0. And then from there, what we have is we have e to the x, because again we're taking the derivative, and the derivative of e to the x is e to the x. And then plus, and then what we do is we have the second term, the g prime of x there, e to the x. So that's just it as is, that's it when it's differentiated. Sorry to confuse you here, again it's just product rule, and then that's multiplied by a half, so we get half e to the x. Hopefully this video has been okay for you to follow along with. If you have any questions, please leave them in the comments section below, and thank you very much for watching. More videos coming soon.